You are ready.
Cool. Hi, we are the Co-op, and today we're going to be talking to you about our first sprint for Explore Interactive. So this is our team. We are comprised of Aaron, Jason, myself, and Lizzie. And so today we'll talk you through a little bit of the project background and objectives, our research and findings, the problem that we identified, our design principles, our user personas, and then we'll go into next steps. And at the end, we'll have some time for questions and feedback. So some background. So we know that Explore created this augmented reality game that teaches STEM concepts to elementary students. And Explore wants to expand this game to teach all elementary levels, but right now they're focused on 3rd to 6th graders. The current content focus of this game is on energy and circuits because it's being developed in alignment with next generation science standards. And also to note, the game is only available on iOS mobile devices right now, so iPhones and iPads. So this is just a snapshot of what the game looks like. We got ourselves acquainted with it. We downloaded the app, printed out these cards that you use along with the app, and we talked to the client. We talked to the client to understand what their vision was for the game in the future, and then what they wanted us to design for. So the challenge that we were presented with primarily has to do with onboarding. So the current game doesn't have any sort of onboarding within it. It doesn't teach any first-time users how to use the app, and there aren't any instructions to guide a user through it. So that's kind of our main element that we're going to be designing for. Another part of the challenge is to consider engagement, thinking about how the main users of this app are going to be elementary school students. And finally, the client is really focused on error handling. So Ariella, who's the technical team lead for Explore, when we talked to her, she asked the question, how do we tell users that they're wrong? And that space is kind of a teachable moment for the kids using this game, teaching STEM concepts. But the overarching theme when we talked to them was that they wanted us to integrate storytelling throughout the entire experience. So this is kind of a snapshot of our whole challenge for this design project. But before we were going to address the challenges, we had some objectives in mind. So first, we wanted to explore trends in AR, mobile gaming, STEM education, and ed tech. So these are all areas that we as a team were previously unfamiliar with, but these are all areas that Explore Interactive touches. So we wanted to get acquainted with what the current landscape looks like. We wanted to understand the habits and interests of elementary age students. This is the target audience of the game, and this would help us understand kind of how they are best engaged. We wanted to acknowledge potential constraints that teachers have when they acquire supplemental class materials because Explore Interactive is a supplemental class material. And finally, we wanted to gauge current student perception of STEM. So with these objectives in mind, we started to dive into some research.
I'm Lizzie, and I'm going to talk you through the beginning stage of our research process. We started with some domain research to understand the industries that Explore Interactive is anchored in. Ed tech is the first industry we looked at. 83% of teachers feel positively about virtual reality in the classroom. The challenge, though, is for schools to pick products that significantly improve learning outcomes in the classroom and not just things that end up being cool to have or just a kind of frivolous addition. So schools really want to get the most out of their investments. The second area we researched is augmented reality. The good news for Explore Interactive is that augmented reality is a growing industry. You can break down augmented reality companies into two categories, one being content focused and the other being technology focused. The technology focused companies are really focused on preventing user errors, while the content focused companies are really preoccupied with the storytelling or story living as the reason for users to want to come back and to continue to use their products. The third area we researched is AR games for kids. So AR games tend to be content focused. like we talked about in the last slide, that means they are focused on storytelling, missions, and goals as a way to progress the user through their game. Because it's content focused though, these companies do suffer from some usability issues. The ability to move around physically and manipulate your environment is a crucial point for augmented reality games. The last area of our domain research is STEM, which is science, technology, engineering, and mathematics. Some shared characteristics of STEM lessons are that they include hands-on exploration and creation. They integrate 2 or more subjects. They have a connection to real-world problem solving, and they use technology to facilitate learning. So the other part of STEM is that it's being pushed at really young ages because young learners are actually very able to comprehend STEM concepts because of their natural sense of curiosity. And this push is also happening because the US has very low numbers in STEM graduates as compared to other countries, as well as low STEM test scores. So after this domain research, we were able to identify our key competitors. We synthesized this information into this chart where you can see the vertical axis, which shows the intended environment for the product to be used, and then the horizontal axis, which shows how the objectives are being pushed to the user, so either through games or instructions and models. There's an empty space here in this upper left-hand quadrant that gives us some great opportunity space for Explore Interactive. The next part of our research was to start interviewing users, and I'm going to let Jason walk you through that.
Thank you.
You're welcome.
Hello, my name's Jason, and I'm going to go over some of the findings we have as it pertains to our user research. First thing we did is we started taking a look at who we thought would be good people to interview as far as users were concerned. We had 2 categories we focused on, the first one being teachers and the other one being students. We did really well in going through and finding a nice mix of regular educators as well as special ed, and we also were able to hit somewhere in the grade levels that we were trying to as it pertained to what was going on with our client's product. We also went through and we found students that fell into that age range as well. So this is a snapshot of just kind of the opinion that one of our user interviews went with a teacher as it dealt with time constraints. And here's a list of some of the other takeaways that we had. One thing we did find out about is how technology was used and adopted into the classroom. And as I mentioned with the last slide, we also got a pretty good idea how time constraints play a really large role in whether things are going to be adopted and used as well. We got an opportunity to speak with the teachers and find out what their attitudes were towards technology and what budget issues were involved with it. And we were actually pretty well educated now on how that works at a local or a state level. This is a quote that we have from one of the students we interviewed. We thought this was a really good indication of essentially how they really like interactivity. They also enjoy being challenged as well. And so some of the key takeaways from our student interviews is they had positive engagement through gaming in school. We had one situation where one of the students explained to us that he didn't really care for spelling so much, but whenever he played the game Sparkle, he was more engaged in learning it. They also gave us some pretty good insight on some of the game features that they enjoyed, as well as their perception of STEM curriculum in school. To our surprise, both of our students we interviewed enjoyed science. And they also enjoy having creative freedom in how they go about doing their learning and their lessons. So after we went through and we summarized the information from our user interviews, we started making notes with them on the Post-it notes on the board here and started organizing it into our affinity diagram. And from this, we were able to go through and calculate out some topics that helped us to derive our research into defining our problem. I'll let Aaron cover that now.
Hello, I'm Aaron, and taking all of our research and extracting some of the key takeaways, it helped us develop what we felt was the real problem here. And our problem is that teachers of 3rd through 6th grade students need a supplemental tool for their STEM lessons in order to engage their students in a fun and meaningful way, and build positive connotations to STEM that encourage further exploration. Following the creation of our problem statement, we wanted to create some of the main pillars that our design would be built on, so that we could continually keep the needs of the users in mind and at the forefront of our decisions. Our first design principle was fostering growth. The content needs to be challenging but allow room for trial and error, leading way for growth, development, and a sense of accomplishment. Drive it home. The decision will aid in progressing the game through storytelling, incentivizing users to continually achieve new goals and encouraging maximum recallability. Easy to implement. The product should allow teachers to implement at their discretion without time commitments or specific curriculum requirements. And finally, no previous experience needed. The product should be able to suit the individual learning level of all students using it, and inspire them to experiment with concepts inside and outside the application. To continue on with this idea of always keeping our users' needs in the picture, we developed 2 user personas that captured all the key takeaways that we gathered from user interviews. Our first is Brody. Brody is a 10-year-old. He's from Nashville, and his goals are to be able to understand his assignments and to have a way to showcase his creativity. Some of the issues that he has is that he finds it difficult to retain information when the majority of his assignments are reading or writing, and he feels he learns better when he's more active and hands-on. He also doesn't like having to be right the first time. So if he makes a mistake, he wants the ability to go back and figure out the decision on his own. And behind every good student is a good teacher. So here we have Bonnie. Bonnie wants to be able to find new and intriguing ways to teach her lessons. And she also wants to be able to add more games to her lessons, because she knows that students remember more from games, but the games also need to fit into her lesson plans. And this leads us to her pain points. The games need to be exciting enough to keep her students' attention. That way she isn't wasting her time with games that will bore the students and they won't retain anything from the activity. She also needs something that has a real-world application, because a lot of the STEM resources that she has, it doesn't currently fit that need. And finally, the design needs to be exciting, because she's very suspicious and she judges tech that has poorly designed features and user interfaces. At this point in our project, we've finished up with our research and synthesizing that data, and we'll be moving into concepting and concept testing. And this concludes our presentation, and we'd like to open up the floor for questions.